Okay, welcome everyone. So the type of experiment I'm going to demonstrate is called the balloon geometry experiment, which consists of different types of molecules with different electron domains and as well as different comparisons between lone pairs. So the first type of molecule I'm going to introduce is AB2, which consists of 3 electron domains in which the electron domain geometry is called triangular planar, which consists of 1 lone pair. So this is the configuration of how it would look for the AB2 molecule. And so my next molecule I'm going to demonstrate is AB3, which consists of a total of 4 electron domains with electron domain geometry of tetrahedral with only 1 lone pair. And for that, this would be the configuration for AB3. So the next submolecule I'm going to introduce is AB2, which consists of 4 electron domains. The domain geometry is tetrahedral as well, completing with 2 lone pairs. And so I'm going to demonstrate by doing that as well. So it's basically kind of like the same configuration I showed like maybe a couple seconds ago. There you go. Next molecule I'm going to introduce is AB4, which consists of 5 electron domains. The electron domain geometry is trigonal bipyramid, which consists of a number of 1 lone pair. So here's the configuration for that molecule, as you can see, in which I figure it is, but there you go. Next molecule I'm going to introduce is AB3, which also consists of 5 electron domain pairs with 2 lone pairs, as well as the electron domain geometry is triangular bipyramidal. And so for the same configuration as with that is like the one I showed a few seconds ago as well. And then for my next lone pair is AB5, which consists of 6 electron domain pairs as well as the domain geometry of octahedral, which consists of 1 lone pair. And for that, the configuration will look something like this, with 4 balloons on the side, with 1 on top and 1 on the bottom. And for my next one would be AB4, which consists of the same amount of domain as AB5, which is 6 electron domain pairs, as well as the electron domain geometry is octahedral, which consists of 2 lone pairs, as you can see. Next example I'm going to configure is SO2, which consists of 1 lone pair, the placement as well, 1 lone pair, and the molecular geometry is bent. And so this is how the configuration of that one is. Would be similarity like this. Next molecule I'm going to introduce is NH3, which the molecular geometry is trigonal pyramid, which consists of 1 lone pair. And so with that, it's going to be something like this again. And then for example, for H2O, the molecular geometry is bent, and so the number of lone pairs is 2, which would be the same thing. And so as it goes on and on, These are just some examples such as SF4, CIF3, IF, -2, BRF5, and XEF4 are all considered within the different geometries such as square planar, square pyramid, T-shape, seesaw shaped, and bend. But the other configurations that I saw were demonstration of different molecules that had different amounts of lone pair and electron domains, but with both similar molecular shape, which makes a big difference in how the balloon geometry works. So hopefully that kind of gave you an idea of what the experiment is. Hope you enjoyed. Thank you.